As well as working at AWS, I'm also a long-term video game player. I've played video games all my adult life. In fact, I spent a lot of, I would say long nights, but a lot of all nights when I was at university in the UK, playing video games like Super Mario Kart and Shadowrun on the Super Nintendo. That ages me pretty accurately. And I'm here today to talk to you about how video game developers can use AWS as a back-end platform for delivering compelling and rich gaming experiences to their audiences around the world. I'll also talk a little bit about the level of seriousness for Amazon Web Services in investing in the video gaming market as an area of service development for us. How many people here are games developers? Do we have any game developers in the room? And how many people here play video games? Okay, I can see why you're here then. Okay, guys, okay. So maybe you'll learn a little bit about how games can be built using AWS in this session. And if you're a game developer, maybe you'll learn about how you can build your future products on this platform, okay? So, what is the state of play with gaming in the AWS cloud today? Well, if you roll the clock back a year ago, maybe 18 months ago, we had a lot of customers that were using AWS in quite a traditional way to build back-end services for gaming. And when I say using AWS in quite a traditional way to build back-end services for gaming, there's really two primary use cases, okay? The first is running API or web services infrastructure to support control plane activities for video gaming services. So here we're talking about developers that are running things like matchmaking services in the cloud, player identity. Maybe they've moved the data model out of the client or out of the real-time engine. And if you're talking about MMOs or multiplayer games of any type, maybe they're storing game state inside web services that they're exposing to their front-end infrastructure. That might be on mobile, it might be on console or PCs. But they're doing that using quite a traditional approach, an approach which is not dissimilar to the approach that you might build if you're building a regular application or a regular mobile app, okay? So we've got a lot of customers that used to use AWS in that way, and you can see a selection here. Just to try out a few of the highlights. So Supercell, you might not have heard of as a brand in its own right, but I'm sure you've heard of Clash Royale, which Jeff mentioned in the keynote this morning, Clash of the Clans, and Boom Beach. These are some of the most popular and actually some of the highest grossing mobile games on the planet today. And as part of my role, actually, I speak to customers in a variety of different sectors. I'll often talk to customers that might be working in energy and utilities or financial services about what they can learn from some of the challenges that are faced by organizations like Supercell. We'll talk about some of the changes in gaming in a second when I flip on to the next slide, but there's a lot of difference in the way in which games are distributed, monetized, and managed today if you compare it to how it used to be when I started playing video games in the mid-90s. And we've got a broad range of other use cases across other types of product here, so not only mobile, but also AAA titles on console with customers like Ubisoft, and AAA titles on the PC as well. So we've always had good adoption in this marketplace. What are the challenges that I talked about a second ago? So there's a lot of big change underway at the moment in the gaming market. And if you're older, like I am, I consider myself to be, you'll remember what the model used to be like, okay? We used to buy video games from shops. Does anyone remember that? You go into like a retail store, you buy a cartridge, and on that cartridge, inside that cartridge would be some silicon, and on that silicon would be a copy of Super Mario Kart. Do you remember that? Who remembers that? Some people definitely remember that, okay? Now, how different could gaming be today in comparison to that? The relationship that you had with the publisher was like a once every 2 to 3 year relationship, right? Every 2 or 3 years you would go into a video game store and you could lay down your $50, maybe £39, I'm from the UK, and for that you would get your product, okay? That would be it. You have no other interaction with the studio beyond that exchange. Okay, there was no opportunity for the product to be played on any other platform other than the platform that you'd purchased it for. You'd be locked actually to a specific console generation in most cases, okay? So you didn't have this idea of long-lived multi-generation IP. It was just starting with things like Super Mario, where they made the jump from the 8-bit NES onto the Super NES, but it wasn't you know, the substantial sort of generational based model today where you've got customers, players, that have got long-term relationships with video game IP. In fact, some of these players have got better long-term relationships with video game IP than they've got with members of their family. Okay, you've got a better relationship with the heroes of Final Fantasy or the heroes of Super Mario than you might have with your own family. So you've got this multi-generational model. We've also seen this shift to mobile gaming, where the vast majority of growth in the gaming market does not come from traditional platforms. It does not come from PCs or consoles. It comes from these, okay, from mobiles, from people that are playing on mobile phones and tablets. And actually, the side effect of this is it's opened up a whole new demographic for gaming IP. Do you know the fastest growing segment to get today in gaming is women aged 21 years and older? Okay, so people like you, okay? You actually are the face of the growth in the video gaming market today. You've got this free-to-play model, so there's no longer requirement for the player to lay down money to access the IP. Laying down money is something that you do for progression or because you want to further customize or enhance your experience. And you'd be familiar with League of Legends, World of Tanks, World of Warships. They've all got huge franchises which have been created under this entirely new model where there is no upfront payment for the product. The payment for the product comes as an accelerator for progress or for allowing you to customize your avatar in the case of League of Legends, for example. Also, you've got additional revenue streams that come from this, you know. It's no longer all about the people that are playing the game. That's not the only source of revenue. What about esports? What about the communities that develop around this IP, which in many ways are as big as the communities that develop around the property that's produced by major movie studios? You know, you've got a completely new dynamic in the market because of this audience enlargement, and you've got global reach, and you've got this fundamental issue with free-to-play that you don't actually start to drive revenue out of the products unless you're sustaining these relationships with customers. So it's one of those situations where you could say, you know, situation is normal here, everything has changed. It's totally different to how it used to be 15, even 10, even 5 years ago. So how do you respond to that? How do you deal with some of these challenges? How do you get your game to be a viral phenomenon? How do you get it to spread? Okay, how do you deal with re-engagement, with getting customers to come back and engage with your game's IP repeatedly, either within the same title or across these generational gaps? And this is a highly, highly competitive landscape. I don't know how many apps you have on your Android or iOS device that you allow to send you push notifications. I'm guessing a lot, okay? I have a lot of them. And there are many techniques that game producers will use to try and sustain this level of engagement across the life cycle of a title so that they can deal with some of those challenges that I talked about on the earlier slide. Just a final piece of context, of course, is to do with scaling. And as with every discussion that I have about this topic, there are really two different components here, okay? So the first is, in console titles particularly, there is a very peculiar, a very characteristic scaling curve that is followed in these titles. So I'm DICE, okay? It's part of EA. My IP includes Battlefield 4 and Star Wars Battlefront, okay? I've got 20 million pre-orders for Star Wars Battlefront. How many users do I have on day one when the product is launched? I have 20 million, okay? So I've gone from 0 to 20 million subscribers, 20 million users of my product in a day. It's relatively predictable because I can see through physical product pre-orders and online pre-orders what my kind of level of usage is going to be. So at least I can predict for the spike. But the bigger challenge then is, with console titles particularly, you see this peak, and then you see this scale down. Okay, so you'll get this ramp away, and then the console publishers will try to reinvigorate interest and generate additional revenue with downloadable content with DLC, which will spike usage again. And then you get the same thing. You get this decline. There'll be a little bit more DLC, and you'll get this decline again. So it's a model of scaling which is very, very difficult to manage with traditional infrastructure models. In fact, it's almost impossible to deliver the player experience that you want if you have to build your infrastructure out in a traditional manner. There are a tiny number of organizations that do it, but they're very few and far between. And then the other side of that is mobile, where it's quite literal. If you've got a title which is a viral success, a title which is not heavily promoted but has something unique which appeals to a large proportion of your potential player base, you literally have no idea from day to day whether you're going to have 10 million or 100 million users of your product. Okay? And with open access app stores, you can have a different kind of problem. You can have a problem which is just that it's very difficult to deal with scaling. So how do you build and maintain an architecture which allows you to deal with those two challenges? And obviously, the cloud and AWS is a very good way to deal with that. So, if we'd been here a year ago, I'd be talking to you about this. Okay, I'd be talking to you about using AWS in two different modes to support gaming operations. One would be a web services model. We've been encouraging you to turn your game backend, the non-real-time components of your game backend, into a collection of web services, delivering them over the HTTP protocol using RESTful API design patterns. And actually, probably if we updated this talk today, I'd be saying right now the same things that Danilo just said about converting your game into a set of serverless microservices and having that same distributed, loosely coupled architecture that you heard about a second ago for those example web applications. And that is still current. You may still do that, okay? That could still be a feature of your platform. But what we've seen is a shift in the way in which games developers are making use of the cloud, getting away from this model of having to maintain large fleets of infrastructure for essentially serving web APIs behind their titles to maintain things like game state leaderboards, item databases, and player progress, and instead moving to a different model. And this model is essentially a serverless architecture specifically for games developers, okay? And we've done some things at AWS to help developers move into this mode of operation. The first is in SDK delivery. We've delivered 2 SDKs that are specifically intended for use by games developers. The first one is an SDK for Unity. Many of you will know Unity as a popular cross-platform 3D game engine which uses the C# .NET style programming model to enable you to embed custom logic into the engine and to extend the engine. So you can create, update, and modify entities inside your game using either the editor that they provide for Unity or using your own code which runs on top of the engine which you're going to write in C#. And what we shipped for Unity is a specific SDK which enables developers, games developers that are using Unity to work directly with AWS service endpoints. Now, has anybody here played a game called Rust? Good man. There's one person that's prepared to volunteer that he likes hitting people on the head with a rock on a beach, right? It's a key game mechanic in Rust, okay? Now, Rust is written in Unity. It doesn't actually use the architectural model I'm going to talk about in a second, but it could. When you log into the game, there's a really cool thing at the bottom which is intended to give you the feeling that you're part of a massive global player base, okay? And that is a counter. It will tell you at the bottom of the screen how many people have been killed since the game launched by bears, okay? Or how many people have been killed by bows and arrows, or how many units of a particular type of crop might have been farmed in the game. This is a survival game, okay? Now, the way that you could do that is by using our Unity SDK. Each time an object is created or destroyed in the game, so an entity is created or destroyed, you could talk directly to our DynamoDB service endpoint, and you could increment atomic counters inside DynamoDB tables that hold information about the number of times that that particular event has occurred in the game. So each time one of your bear classes gets deconstructed, in the deconstructor function, you'd implement a counter. Next time a player wanted to know how many times that event had happened, you would just read the same counter out of the same database table using another method within the SDK. Okay, so you have a serverless model for games development where rather than having to build and maintain a back-end infrastructure, it's just your code running inside your clients, inside the engine on the console, the PC, or the mobile device, talking directly to AWS service endpoints. And we provide this SDK to make that a simpler process for developers to execute, a simpler set of features for developers to build, essentially. Okay, so that's Unity. Here we have service coverage, which is all about working with endpoints. Okay, so we don't, with the Unity SDK, have the ability today for you to create resources. So you would create resources independently, and then communicate with those AWS resources using identities that you might gain from Cognito, together with IAM, and then a variety of different service endpoints that you can talk to. So that's .NET on Unity. The second thing that we did a little bit later, this is a little bit more significant for a reason that I'm going to talk about in a second, is ship a C++ SDK for AWS. So here we have more comprehensive coverage, both for working with service endpoints, so I can do the same things, I can increment those counters in DynamoDB, I can create new documents in a DynamoDB table, I can retrieve data from DynamoDB, I can insert objects into an SQS queue, I can initiate Lambda functions either synchronously or asynchronously. I can do a lot of other stuff as well with the C++ SDK. But I can also operate creation or take creation, modification, and destruction operations on AWS services as well. So I can write my own code in C++ that's going to spin up EC2 instances, that's going to create tables, that's going to substantially modify my AWS environment, and I can do all that directly within the SDK. So why do games developers like to use C++? It's a very simple question to answer. It gives much finer control over network and graphical performance and memory management. And in latency-sensitive games like first-person shooters and increasingly MMOs, that's actually very important. You can't have performance variability. It can't take you 30 milliseconds to land a blow if we're playing a fighting game, and take me 150 milliseconds, because I'm going to have a terrible experience and you're going to have a great one. So this fine-grained control over the client environment is the reason that these developers tend to gravitate towards C++ development. And actually, under the covers, Unity itself is written in C++, but Unreal Engine, the Crytek engine, and actually the majority of other games engines are also written using C++. And this is the extension language that is used for creating additional modules and additional functionality for these engines. So using this SDK, you can extend Unreal, you can extend Crytek, and you can extend other 3D engines as well. So after that, we did this. This is a bit more of a radical departure for AWS and for Amazon. And Lumberyard is a set of tools that are targeted specifically on games developers. Okay, so we're going beyond what we did with our SDKs, and we're now really committing a serious amount of R&D resource and a serious amount of expertise development to this particular market. And Lumberyard comprises two different components. The first thing we have is we have a free-to-use AAA game engine. A game engine is the piece of software that runs on your console, PC, or mobile device that maintains the state of the world that you see when you're playing a game. So it's the physics, it's the thing that makes bullets go in a straight line or curve, depending on the demands of the developer. It's the things that makes vehicles bounce off each other in a representative fashion if you're playing a driving game. It maintains the 3D models that constitute the environment, the physical properties of those 3D models. It also has some other very useful features, like modern games will mostly have spatial audio in them. If I'm looking at something in my video game and I have an appropriate pair of headphones or a sound system on, I'm going to be able to tell if the sound's coming from here or over here. That's, again, another feature of a 3D engine. So it contains all of the systems that game developers need in order to create this immersive 3D or 2D experience, which is present in the vast majority of modern video games. And the ones that I've talked about already has been significant here are things like Unreal, Unity, Crytek. They are 3D engines that are offered under a variety of different licensing schemes, actually, that enable video games developers to focus on the content and the experiences that they want to create, not on building physics models and on building 3D audio systems. It's the kind of undifferentiated heavy lifting that we always talk about in operating IT. The games engines do that activity for games developers. So what is Lumberyard? Well, Lumberyard is a fork, a derivative of the Crytek engine that Amazon has taken and incorporated additional IP into. And some of the additional IP that we've built into it is things like our own C++ SDK. So it comes ready to go with native integration with AWS services. We've already integrated our entire C++ SDK into the engine. The other very interesting characteristic of Lumberyard is there are no costs, either per seat developer costs or revenue share distribution costs, if you choose to build games on the engine. There is one licensing restriction, which is if you're going to use a cloud service in conjunction with your game engine, and AWS have a cloud service available which fits the particular use case that you intend, you have to use ours. So you can't use Lumberyard with third-party back-end services where AWS offers a comparable service. Okay, that's the licensing restriction, but you can distribute 10 copies or 10 million copies of a standalone game that doesn't use any cloud services, and it won't cost you a penny to do so. Okay? We're iterating on this at the moment, so we just actually hit the 1.3 beta. This is the 1.2 beta, which is talked about here, and I'll talk later on about some of the enhancements that we've made and some of the additional features, but that's a big component of Lumberyard. This is what the editor offers. So we have a visual editor. This is the Lumberyard editor running on a PC. Obviously, it requires a pretty powerful machine to run the editor because you can drop out and see the interactive game mode. There's a modular development model with gems. We have both the 3D editor, which is intended for the in-game experience, as well as 2D and UI interface editors, so you can have 2D matchmaking, splash screens, and other 2D features, and then drop into the 3D experience for the game itself. We have an entity and component editor, which is a hierarchical object-based model for creating entities within the game that have logic, behavior, physics, other characteristics associated with them. And then we have this visual scripting capability, which we call FlowGraph, which is intended to allow non-technical games designers to create game systems or modify game systems without needing to have C++ expertise. Okay, so we have a visual editing component in the editor as well. It creates things that look like this. So these are demos that were created for GDC in the US a couple of months ago now. So this is a 3D exterior environment with complex lighting, obviously with rendering. It's all rendered in real time. You can walk through that environment. It'll be rendered in whatever frame rate your video card is capable of driving it at. This is character rendering. This is a model that was created. Again, it's rendered in real time, high definition character rendering. You might like the reflected light sources in the eyes. They're pretty cool. It's quite a nice feature with the external lighting there. This is a super close-up of the same model. So we've got very high texture quality here and very high rendering quality. And this is typical of what you'd see not only in our engine, but in modern AAA quality engines like Unreal. So it's comparable quality to other engines that are out there. The second component that we have is something called GameLift. This is a little bit more AWS-y in flavor. Okay? And this is intended to simplify that issue that I talked about earlier, which was console and PC games. On launch day, you have huge numbers of players, and you want to manage a fleet. Okay, so here we're not talking about those asynchronous or non-real-time services that we need to run. We're talking about real-time game session servers. So I'm playing a session of Battlefield 4 or Star Wars Battlefront or League of Legends. I have a matchmaking process where I'm matched with other players, ideally other players that have got similar skill levels to me or similar experience to me. Then I'm dropped into a session. I'm dropped into a game that lasts maybe 45 minutes to an hour in the case of League of Legends. Maybe a little bit less than that with Battlefield, but essentially players come together, they congregate around a particular session. The session runs, it ends, and then they do the same thing again. So you have a large fleet of EC2 instances in the case of EC2, in the case of AWS, that you need to maintain. You need to determine where these sessions are going to terminate. You need to deliver players into this environment that maintains shared state. You know that I've shot you because the game engine communicates with the back end, and the back end tells you that you've been hit by a bullet. That's really what's happening in the game. And that is a very heavy process for games developers to essentially turn themselves into operators once the title's been launched. What we've done with Lumberyard GameLift, Amazon GameLift, is provide an abstraction layer that enables games developers to manage these fleets in a logical way without having to think about or focus on the infrastructure requirements. Okay, so you can deal with matchmaking, you can deal with delivery of users onto sessions, and you can also simplify some of the lifecycle issues that occur. So I mentioned I'm going to have a large piece of downloadable content that's going to drop soon for my title. Well, I probably need to up-rev my engine at that point and introduce some new features into the engine that I'm running. So how do I manage the lifecycle of connecting players that are on the DLC content onto the right engine version, and connecting the other players that have not yet acquired the DLC onto the pre-existing version of the engine, scaling that one down and gracefully scaling this one up. And those are features that are provided within the service. So you've got version management, uploading binary packages. You create a build catalog, which is a logical construct that lives in the AWS cloud where you store your images. And then you can create multiple concurrent fleets. The fleets can be scaled dynamically. And we use metrics here that are relevant to the player experience when you're starting to match up players with session servers. So, I mean, as you might expect, it's not CPU, right? Because you want to run your session servers very hot, but just because you've got a lot of fully populated session servers doesn't necessarily mean that you need another one. You know, things that are relevant are how many players are currently in the matchmaking queue. And you want to have enough capacity to place all of your current queued players onto instances in a fixed amount of time, or maybe even slightly more sophisticated than that, how quickly is the length of the matchmaking queue changing? Am I seeing an upslope where I'm starting to get more players joining quite rapidly? You know, is it out of school time for the 13 to 17-year-old kids that make up the target demographic for my particular piece of IP, and therefore can I observe this happening in different regions around the world and use the features of the service to pre-position capacity so that those players have a good experience. These are the kind of metrics that we built into the service. And you'll see this, you can have builds and then multiple builds live concurrently, pushing those out for your own users that you might have in test, your beta test community that might be public, and then of course production versions of the product that are running for mass utilization by the majority of the current player base. And we also produce metrics like this so you can see where you're at in terms of consumption of the different versions that you have, and also consumption of low-level infrastructure resources like CPU utilization, network capacity, and other metrics that might be relevant to the player experience as well. Okay, Cloud Canvas. So this is our visual scripting engine. What we have here is this visual tool that enables you to give the capability to change the game design to less technical users, so you can modify game state as a designer without having to dive into C++ or other programming for that matter. So you can directly access AWS resources from within this console with this visual scripting environment, and then our back-end system manages the creation of the AWS resources that are required to implement whatever features have been designed within the scripting engine. So if I, for example, specify that I'm going to be using a new DynamoDB table for a particular piece of front-end logic, when I deploy that, that table will be automatically created in my AWS environment, in my account, using credentials that are embedded within the editor. Okay, so your designers can directly create resources without having to know anything about or dive into the AWS console or other AWS tools. It's all put into a native environment, a native tool that designers and game developers will be comfortable with. And then lastly, we have this. So all know about, does anybody not know about Twitch that's here? Okay. A few people? No, you all do, okay. This is a video game streaming. Can you believe that on any given night, around the world, millions of people are getting entertainment by watching others play video games? It's true, it's true. It's true. They've got a massive community now, and this is a company that Amazon acquired a couple of years ago now. The broadcasters, the people that stream games, become huge personalities in their own right. I mean, you'll know the most popular YouTuber on the planet is a guy called PewDiePie, right? And he streams, well, broadcasts video gaming segments. So this is turning that phenomenon into a live entertainment phenomenon, okay? 100 million unique viewers every month, with peak concurrency of 2 million concurrent viewers. So it's the size of a very large TV channel, really. And what we've done with Lumberyard, with the Lumberyard release, is provide integration between the game experience for players and watchers and Twitch itself. So there's a couple of things that you can do with these integration points that we've provided, but they're intended to help players and game IP owners build stronger communities. The first is something called Twitch Chat Play, okay? And this allows viewers of a player's stream to influence what's happening within the game, okay? So you can vote effectively inside the real-time chat which sits alongside a streaming session, and you could vote for events to happen in the game. I want to spawn a bear, maybe. And if enough people vote for that activity, it will influence what happens inside the player's session, and maybe an angry bear will spawn next to them. Okay, so it's intended to introduce real-time interactivity between the people that are watching a broadcast and what they're watching. The second feature is something called join-in, and this is something that sits with the broadcaster. You know, you can interact with me in my Twitch channel, and I can pick you up and teleport you into my session. So a minute ago you were watching the game, but now you're inside it, inside the same 3D world, actually playing in the session with me in real time, just by me clicking a couple of buttons inside Twitch and having the appropriate integrations, of course, in the game engine and back end. Okay, so it's all about trying to move the interaction model with viewers of Twitch, enrich it, and allow games publishers, games developers to build an even stronger real-time community around their IP. Okay, so I've talked about a lot of stuff there. I'm out of time. If you want to learn more about this, go here. We now have a vertical-specific blog that's focused specifically on game developers, and we include a lot of technical articles in here, a lot of getting started articles, and a lot of guides of how to get stuff done. Here's one recent example, and this is one for people that play games but maybe don't know a lot about how they're built. So have you noticed that how, when you used to play games, you would walk along a beach, maybe, or see a tree, the beach would repeat every 30 meters, the texture, and all the trees would look kind of the same. You notice that? Have you noticed if you play a modern video game, it's not like that anymore? Yeah? And this is because there's a product called, it's made by a company called Algorithmic, and it's called Substance, and it's procedural generation for textures and materials. So I have a mathematical model for a piece of tree bark, and I generate tree bark dynamically in the engine, and it looks like tree bark, but it never quite looks the same. Okay, so it's a tool that games developers can license to provide a richer visual experience. And you'll find that studios, games developers, they develop workflows that allow them to integrate these additional tools into their creation process, okay? And what we announced quite recently was integration in the engine. Here you can see a car, looks like it's in Cuba, maybe, from the 50s, rendered with perfect paintwork, okay? And this is using textural assets that are procedurally generated upstream. So I have an algorithm, a model that I've defined, which defines a certain texture and material consistency for this vehicle. What I've done over here is I've gone outside of the Lumberyard editor, and I've modified the parameters of the texture and of the material upstream in algorithmic Substance. And through the integration, that flows in real time directly into the visual representation of the material inside the editor. So it's tool chain integration, where you've got visual design and upstream tools that might be audio or visual tools, which can flow directly into the editor, so the designers, the creators can see precisely what they're working with in real time, even when they've got a relatively complex web of different tools that they're using as part of their creation process. If you're interested in this, you can find out more on a recent post on the blog, and also learn a little bit more about how complex the tools environment can be for sophisticated game studios that are producing very high quality IP. Okay, so that's all I have for you. Please give some feedback on the session, and if you've got other feedback, you can find me here as well, so you can mail me if you've got questions, if you want any pointers to any of the resources that I've mentioned during the talk, or maybe you want to play on Steam, send me a note. Thank you.